Hello, everyone. My name is Dinorah Tovar. I hope everybody is safe, and I'm really sorry that we are not able to do this in person. But I'm really happy to be here. I'm really happy to be at Android Summit. So let's get started. Today we are going to be talking about modern security for Android developers. And before we even started, I want to do a little disclaimer. I know every security talk has to have one. And the disclaimer today is about how security is a two-sided coin. And I mean it in the way that you need to be safe so your users can be safe, but also your company, right? You are working for a company, and maybe it's an insurance company, a credit company, a bank, maybe it's a toy game for a kid or something like that. And you need to keep in mind that the person that is using your application is also a human. It's not a user, it's a human. It's a human that is, he probably has some credit loan, some information that he needs to keep safe. And today we're gonna be seeing this in this way, in this new light. Usually when we are doing architecture, we are so worried about what we are gonna use. Are we gonna use RxJava, or are we going to go with coroutines? Are we using live data or Stateflow or something like that? But we should start caring about security in the same way we care about architecture, right? So today we're going to be talking about that. And today I'm going to make a very simple, drawable version of how encryption is simpler. When you usually go for trying to have a block of data, maybe it's a certificate, maybe it's the insurance company information, maybe it's some web token, something like that. This data should be go over an algorithm. This algorithm can be anything. Today we're going to be talking a little bit deeper about Recifer. This go over an algorithm and this generate a key. It can be symmetric, can be asymmetric, and we will go over that. When you have that key, you ended up having this data encrypted, right? That's really simple. It just looks like a straight flow, right? Something really, really simple that we can address, right? But let's see what is going on with encryption algorithms, right? You have Recifer. Recifer pretty much is generate a symmetric or asymmetric key and create this ciphertext at the end of the day, right? It's pretty much the more common, is the one that usually everybody goes for, and it's really simple, right? You have Mac. Mac generates symmetric keys, and it's pretty much very simple, very similar to digital signature, except that that Mac, when it generates the symmetric key, it also has no repudiation policy. But it has authentication and has everything else. Digital signature has this repudiation policy, and pretty much they are same, kind of the same. It has their perks. And the other one is message digest. Message digest, what it does is that it creates a cryptographic checksum. And this cryptographic checksum generate a hash at the end of the day. So you have a message that you want to encrypt, and when it goes for this message digest, it generates a message digest with a hash. I know the reinvent the wheel at all. These are the classes that Google go for recommendation. This is a pretty straight screenshot from the security page of Google. It recommends Recifer, message yes, Mac, signature, and everybody goes like, okay, Dinorah, but what is going on in the recommendation side? In the part that they did say that AAS, CBC, GSMIC, what is that? Well, when you go for a Recifer, this is what you are gonna end up, right? You're gonna get the instance of an schema. This schema is pretty much a couple of selected schemas that already exist. You don't need to create a new one, and I'm gonna tell you why. You have a model, and this model gives you the chance to have privacy integrity, right? Pretty much what it does is that creates a counter for every block of data. It puts your message, maybe your web token, incredible long string or something like that, and it put it in little boxes. So every box that you have is going to have a special size. And this little model is gonna give you the possibilities to have a counter on that boxes. And every block will have a number to initialize a vector for the encryptation, right? And it will help you obviously to manage how the encryption algorithm is going to proceed. And the other part is one of my favorite parts is the padding. The padding is required to encrypt the data in blocks, because every block, every box that you have in the model should be 8 bytes, not more nor less. It should be go for that. So you have this padding for do that, especially when you have data that you want to encrypt that is really long. You can use this padding to make sure that your key is not gonna break the encryption process, right? It's really cool. Like I tell you, there's a lot of many standards, advanced encryption standard. That is Rainbow. That is pretty much something that everybody goes. These algorithms are pre-made. They are secure. They already exist. They are given by Google. They are using for big companies, for encryption companies, for the government, the NCA, the NASA. They use this algorithm. You don't need to create one. If you're trying to create a new one and you are not a security company, don't do it. It's not safe. It's not the best way to go. You can give it a try to these encryption algorithms that already exist. And like I tell you, the mode help you also to give some symmetric or not symmetric keys, and that's a huge difference, right? And paddings help you with the thing that I tell you already, right? You can encrypt a long or a small area. It depends on what you want to do. This part of here, the padding is not obligatory. You can use it or you cannot use it. It depends of your algorithm you are want to use, and it depends of the things you want to encrypt. So I get this question a lot. Everybody asks me, what if encryption is something of software or hardware? Well, it depends. It depends of everything, actually. It depends. You probably have seen this hardware acceleration process. You can put it on your manifest for all your app, or you can put it even in just one XML file or something like that. And usually it helps you to create beautiful and smooth animations, but it also helps you to make some changes in the encryption, right? And it depends on your Android version, because before Android 6.0, the encryption is really different. There was even the biometrics were different. There was no documentation over the biometrics. Google dropped some changes of the documentation that it gives to the retailers like Samsung, Nokia, and etc. And the first time that biometric standard was passed was on that time. So if you are doing support below that, probably the encryption is going to be a little different. And I'm gonna tell you explicitly why. Okay, you have your phone, you have some peripherals, and you have an untrusted area and a trusted area. Inside your untrusted area, there's your application, okay? It's your bank account application, it goes Facebook, Instagram, etc., etc. That is where it is, right? You have your operating system, everything is going well, everything looks smooth, right, Dinorah? And you have your memory, and the part of the trusted area, you have a trusted component. This trusted component is a trusted execution environment where you can execute biometric process and encryption process. This little part exists specifically for that. The encryption happened there, okay? Some more modern forms, especially after Android 9, there was a special part that is called secure element. This secure element is a specific chip, a specific area in your phone that has his own memory and his own CPU, right? And this special part is going to execute your cryptographic movements, your biometric handshakes, and everything that goes in there, everything that it belongs to the Keystore or the Keychain API is gonna run there. But you have to enable that part because it's gonna take a little longer to process some encryption parts if you are using it. You probably know this chip as Titan. This is for the Pixel phones, so you can check it out and see if your phone has already a Titan chip, right? And encryption is hard, but let's see why it's hard. Encryption is hard because somehow over the past of the months, we chose this was the easy way to go, right? We decide this is the correct place to do it. We have an incredible library that already does that for you, right? It's stable, it works for every device. Is this the right way to do it? Well, I'm not totally sure. And I'm not totally sure because you already have something in your phone that is Keychain and Keystore, right? Keychain pretty much is an API for credentials that you can use across all your apps. So you can create your credentials, and these credentials can be consumed by these apps, right? And you have Keystore. Keystore is the incredible part of the world that you should be using for encryption. It's a special place in your Android and that every Android phone has to store cryptographic keys securely. So we don't need to go and do that part, try to execute cryptographic movements on your code when you can, and you should use Keystore for that. I'm not going to talk about a Keychain API, but you can drop me a message if you want to check it out later. So the solution pretty much arrived. This is a new library. You probably heard a lot about that. This new library is already in release candidate 03, and there is an alpha, that is alpha 02, that is working in some things that were missing on the first version. That were not in the roadmap, for being more clear, like rotation keys and the support for KitKat. These right now in the release candidates does only work for Marshmallow and higher. Okay, below that it comes the part of the encryption that is part of Android operating system. So they are working on that, and probably the alpha version already has it. I haven't checked it out. Inside this is using this incredible library that is called Think. It's a closed platform encryption that is open source from Google, and we need to use MinSDK23. I know I saw this tweet about Brian Plummer a couple of months ago, and I need to put it because maybe, yeah, the future is now, and, and you can use it right now. I know it's really difficult to support that your mean SDK goes to Marshmallow. I know it's a little difficult, but you should give it a try, right? You can give it a go. It's incredible. It's open source. It's on GitHub. It's really amazing. Getting back to the crypto library, you can probably see that you already are using some parts. This is the keeper generator that has an instance, and you go to the Android Keystore, and pretty much you put the validation, the start and the end of the certificate, because at the end of the day is that, right? And you can create your certificate. Everything is going well. If you check the if else, you can see that if you are Android P, we are going for the set strong backend. This little line in here enables the possibility to have your secure element activated, and that this code will go over that part to make that execution, right? For the new library, you can do something like this. You can create your key parameter spec, some key name that you can put it the name you want, and put some encryption and decryption purpose. You can put the block modes you want, the padding you want that we already saw on the algorithm. And I want you to leave these two for later on, but you can use it for your biometrics. So they are friends of family. They are friends and they are not enemies. And I mean the first version of the Keystore that you can use right now for encrypt anything, or the new library, right? So the new library, what it generates is that it generates a file, and you can encrypt a file or a shard preference, right? And inside that you can generate a key to encrypt that. This key is gonna belong to a key set that is going to be uploaded as a master key set. So the process that you are gonna have is you are gonna have you end up having a master key and a subset key. And this master key that is going to be here in the ping square is going to be the Keystore, and it's going to be only very referable as a key alias. So that's really cool, right? It's going to be a really tough task to disencrypt your data that you are sending there. And like I say, you can have a shared preference or a file to do it right now. You can create without out of the box without any magic tricks, a master key with the specification of the algorithm you have, or you can specify just specific decisions of what you want to have, right? And you can put it in there, create the master key, and everything is going to be cool, right? Remember, we are going to be talking about the authentication required. Well, this because biometrics can be applied in here. And it can be applied in here because if you're already using biometric prompt enough in your manager, that you should already move from that. And you can start using this to make some encryption. I'm not gonna go deeper on the biometric prompt. You can go to the amazing blog post that Sam Edward has. That is one of the organizers from Android Summit. So you can give it a try. It's really, really cool. But inside the biometric, you need to keep in mind that this is local authentication. This is never going to be able, you will never gonna be able to send that to your server. Don't try it, don't even think about it. It's not safe. Your biometric prompt is going to run over a secure channel when you put your finger or you put your face on it. And one is there, it's gonna unlock the prompt. It's gonna tell you, okay, everything is matching. Okay, but how it works in reality? Well, this secure channel is running on the TTA, in the trusted execution environment, and in all the data that is going on in there is going to be secure. You have three parts that are really important. The first one is that all the biometrics goes for over this of acceptation, range of acceptation. The first one is fault accept rate. It tells you pretty much how many times of the times that is unlocked, one is grown. What? Yeah, that's the specification. How many times the acceptation rate is grown on over the biometric, and the imposter accept rate, it gives you the chance to know how many times of the times you are accessing it get accepted by imposter. And I mean, like, imagine that you have something like a comedian or something like that, and try to unlock your voice, trying to imitating your voice and trying to unlock your phone. It is going in the imposter accepted rate. It's not big, it should never be big, but it can happen, right? And the split accept rate pretty much give you how many false negatives it's gonna give you, right? So your biometrics are gonna go over that part, and you can give it a go, you can give it a try and try to check it if this is ever gonna be break, but pretty much it's not going. So native models, I love native models. There's a lot of apps that still using it. Because there is a myth that C and C++ cannot be decompiled, so you cannot get the code you are using, right? But C and C++ code can be disassembled. And when I say it can be disassembled, is that you can have your code like this, and you have an amazing string that you want to keep safe. I will give it a go, but you can decompile this code, and this is a slim code. It's not the XML, the hexadecimal code, but you can see that for this example, there is a function that is a string from Genie. This specific function can give the access to some attackers to know that there is something in a native code, right? And inside this native code, there is a native library that is being loaded, and you know where it is, how it's called. So give it a try, give it a go. I will not post my JSON token there to access to a server. It's pretty much something that I will try to keep it in the back of my mind to see if I really want to have a secure key in there. right? Especially because you are giving this to you're giving this key to, and multiple developers are going to be working with you. And if something goes wrong, can be grown everywhere. So give it a try. Don't store something really sensitive here. It's really difficult to extract it, but just keep that in the back of your mind. It can be extracted, and it will be extracted if you are trying to hide it way too long. And it can be really more simple, like having something on, I don't know, an Amazon web server or something like that. One of my favorite part is the secure data layer, because sometimes when we are building something for retrofit, so some handshake, we have endpoints for our application. We think that having an CCL and have some HTTPS is gonna make the work go smooth, and it's not like that, right? Uh, if you have this, not everything is going to be cool. Just you have to give it a try to certificate authority. There's two options. You can have a CERT certificate or a PVX certificate. And inside this certificate, they are different. The only difference is that the PVX has many more information, like authentication has a lot of more information that you can have in the CR. So you can have something like this. Yesterday I was giving this talk Drake on MEI, and everybody was asking me, you should not keep that in a raw file. Don't do it. It's just for a classic example. This is grown. You should not keep your certificates as a raw file just in there, because everybody can extract your app and try to give it a go to your images and your routes and your strings and everything going on in there. So what you need to do is that you need to create an instance from the Keystore to put and load the certificate there. You can have a password, you cannot have it. I suggest you have a password. And when you have that, you can create a key manager factory instance. When you create that, you can create a CCLA context instance, right? And before that, you can use something of TCL. And when you can do that, you can put it on your client for okay, HTTP, right? When you do that, you can put your connect timeout, your read timeout, and you will have a certificate to make some handshake with your server when you are trying to make some posts, some will make you happy with it, right? That's pretty much everything from Modern Security for Android developers. I'm really happy to be here, and keep that in mind when you are doing your new application. You are trying to make a safe work. In safety is from our side as developers, and from the side of every user. So keep that in the back of your mind. And my name was Dinorah Tovar, and I'm really happy to be here. I don't know if there's any questions. Haha, there's one. No, there is not questions. Right. Awesome. I think that was all. Okay, I will wait. Thank you so much. You can find Medium blog post when I go a little deeper in every topic that we have in here, especially with certificate pinner, that you should be using Shido's 256 or something else. So you can give it a go. It's in my Medium blog post, and it's a full serial over these specific topics.
Are there any other questions for Dinorah? No? Okay. Oh, we might have someone. There we go.
Oh, okay. Third parties app keys. You mean like maybe some Firebase keys, maybe some I don't know, mixed panel keys. I think that's pretty much. I think that's pretty much okay. I will not worry about that. There are only keys to report your analytics and things like that. They are pretty much okay. You can keep it like that. And it's not that bad. It is I don't know, maybe um, a key to access your Firebase or to your Google Cloud. I will not give it a go in there. Maybe I will put it in some server token, some AWS or something like that, some remote stores that you don't need to access that. I remember seeing issues relying on when the user use face biometric as identifier. Not secure and I will not be able to use on the keys inside. What do you suggest in these cases? Uh, I I haven't seen any issues with biometric SDK. Is that right? I haven't seen any issues with the biometric SDK, um, especially with the face. I don't know how many phones already has it. I think only maybe some Samsungs or high-end Samsungs or even maybe the Pixels. But I think where I saw this issue. Oh, that will be really interesting because it needs to go over. Just let me close the chat. Uh, you need to go over these specific rates to be accepted or and using the biometric prompt. You cannot just put anything you want in there. If it's not safe, it will not go in here. You will never use this biometric prompt, right? This one. You cannot use it if it has not been accepted. So I will give it a go. Just give me a message. Send me a message. I want to know what is going on in there. If there is a real problem that it could go. Give us some issues to everybody in this meeting. No, you cannot. Yes, you cannot change your preferred biometric, right? But you can try to cancel the biometric prompt if you know that the face ID is the first biometric. But I don't know. If you don't have that, then you don't have any biometrics, right? There is not two biometrics in a phone. I think that's all. Uh, Thank you so much for having me. It was amazing to be back at an Android Summit. So thank you so much.
Thanks, Nora. I'm going to stop recording now.